Hey guys, welcome to class. Today we're going to take a look at lesson 5.2 and 5.3 as we talk about adding and subtracting fractions. And we'll do a quick review of adding and subtracting fractions, but really the focus of this lesson is going to be on what happens when we add in negatives when we're adding and subtracting. So let's start with some basic problems that, again, I hope are a review. So we've talked about how when we add or subtract fractions, we have to have a common denominator. And so the first couple problems that we're going to start with are problems where we already have a common denominator. And again, these are much easier to solve because we don't have to do the work of figuring out a common denominator. So if we look at this first example here from lesson 5.2, if we have 7/8 plus 4/8, we already have our things cut into the same size pieces. And so really all we have to do to solve this problem is add 7 plus 4, which is 11. This is 11/8 then as we add those two fractions together. We can actually leave this as 11/8 because that's already in simplest form, or you could write it as an as a mixed number since it's an improper fraction. 8 goes into 11 one time with then 3 left over. So either way would be a correct way to write your answer. The same is true with subtraction. So we must have a common denominator. If you look at the next example, we see 7/20 minus 4/20. Again, there is already a common denominator, so that makes it a whole lot easier. All you're doing is 7 minus 4, which is 3. The denominator stays the same. This is already in simplest form, so we don't need to simplify it anymore because there's nothing that goes into 3 and 20. So that's my final answer. All right, so now that we've done that review, we're going to make a jump here. And again, we're going to be jumping around quite a bit in our notes. So I want you to go to the next page, and we're going to look at a few problems that still have common denominators, but now we have some negatives added in. All right, so as you go to the next page here, let's actually start by looking at number 4, which is the first problem that involves some negative numbers. Okay, so we've had a brief conversation, but let's go ahead and review that when we have a negative fraction, so for example here, we have -1/6, and that negative sign is out in front. And so the conversation then is, where does that negative sign go, or where can it go? And we talked about how we can't put it both places because if we put it on both the top and the bottom, well, the fraction bar means division, and so then we actually have a negative divided by a negative, which is positive. But this fraction is not positive, this fraction's negative. So it can't go both places. However, it can go either with the numerator or with the denominator. Both of those are equal. So all three of those fractions are equivalent. It can either go out in front with the numerator or with the denominator. And this is because we know that a negative divided by a positive is negative. We also know that a positive divided by a negative is also negative because if they have different signs, it's negative. Okay, so if we can put it either place, then the question is, what's the better place to put it? And in these problems where we're dealing with fractions, I personally think it is much easier to keep the negative sign with the numerator. If you put it with the denominator, it starts impacting your common denominator. For example, in this problem, if you wrote 1/6 plus 5/6, you no longer have a common denominator. 6 and -6 are not the same. And so now you don't have a common denominator and you've got more work to do. However, if in this problem, instead, you put the negative sign with the numerator, and so you made it -1/6 plus 5/6, now you do have a common denominator. And so it's a lot easier to keep that negative sign with the numerator so that it doesn't impact your common denominator. Now, in this problem, we're going to apply the rules that we know about integers, and we're also going to apply the rules that we know about adding fractions. So when we add fractions, we've talked about how we add the numerators and the denominator stays the same. So I can go ahead and keep this as a 6. Now, on the top, we have -1 plus 5. All right, well, that's already addition. So now we look and say same signs or different signs. This is different signs, so we subtract. That's 4. The 5 is further from 0, it's positive, so my answer is positive. So I get 4/6, which I do need to write in simplest form, and that is 2/3. All right, let's go on and look at number 5. All right, in number 5, you'll notice that I have a subtraction problem. And so I'm going to go ahead and keep change and make this addition. So this 1/12 stays. We keep the first number. The subtraction becomes addition. The second fraction is negative, so I'm going to make it positive. So this problem now is just 1/12 plus 7/12, because again, minus a negative can become addition. All right, so then when I add these two fractions, I get 8/12. That can then simplify to 2/3. And again, I always want to write things in simplest form. Here, I divided the top and bottom by 4 to get that as a simplified fraction. All right, let's look at number 6 now. All right, again, I have subtraction, so I'm going to make this addition. And as I rewrite it, I'm also going to put those negatives in the numerator. So negative 3/8, I'm going to put that negative sign with the 3. Then I'm going to make this addition. And because I'm going to keep change. So I keep the first fraction, make it addition. The 6/8 then becomes negative. Okay, or again, you could do that within the problem here like that. All right. Now again, I have a common denominator, so that's really nice. The denominator stays the same. Negative 3 plus negative 6. Those are same signs, so I add them and keep it negative. And that cannot be simplified anymore, so you can stop right there. You could also put this as negative 1 1/8, but you don't have to change it to a mixed number. All right. Let's look at one more problem with common denominators, and then we're going to move on when they don't have those. So let's jump to number 8. Again, I'm trying to focus on the problems that have negatives since that's the newer skill here. So I would personally change these to improper fractions before I started doing things. You don't have to, but especially when we're dealing with negatives, I do think it is much easier. So remember we talked about here when we convert, we essentially ignore the negative sign, make it an improper fraction, add the negative sign back on. So 6 times 3 is 18, plus 2 is 20. So I'm going to make this negative 20/3. Again, I put the negative sign in the numerator. Then the second one would become 10/3 because 3 times 3 is 9 plus 1 is 10. All right, the denominator's already the same. That stays the same as 3. Negative 20 plus 10, I've got different signs, so I subtract. The 20 is further from 0. It's negative, so my answer is negative. Also, I didn't say this on the previous ones, but just so you know, negative 10/3, you could also put that negative sign out in front. These are equivalent. It doesn't matter which way you do it. Again, I just kind of keep it with the numerator since that's where it already was. But just so you understand, those are equivalent. They both work great. You can stop right there because that's in simplest form, or you could say 3 goes into 10 3 times with 1 left over. Don't forget your negative sign with your mixed number that goes out in front. So this would be negative 3 1/3. You don't have to change it to that, but you can. All right, now let's go ahead and jump to lesson 5.3, which is now where the denominators are not going to be the same. So we're just adding in one extra step there. All right, as we move on to lesson 5.3, you'll notice that actually this first question is one we've already looked at when we started talking about adding and subtracting fractions. But the question is important, so let's review it really quickly. And that is, why do we need common denominators when we add or subtract? And if you remember, as we talked about this pizza problem, and we talked about how there's half of a pepperoni and a third of the cheese, those are not equal size pieces, so we can't count that as just 2 pieces. So the whole point here is that when we combine things, we have to have equal size pieces. And the only way for us to have equal size pieces is for whatever we're combining to be cut into the same size, and therefore that would be the common denominator. In this problem with the pizzas, we talked about how each pizza, if it were cut into 6, would then have equal size pieces in both pizzas, and so then we can combine them and talk about them more clearly. And so that's the reason we need common denominators, is because we can only combine things or take things away that are the same size, and the way to get them the same size is to have a common denominator. All right, so let's do a review of a problem real quick without negatives, and then we'll jump into the ones that do have them. So as you look at this first example, 7/15 plus 1/5, you probably see that 15 would be the easiest common denominator to use because I can keep the first fraction exactly as it is. I'm going to multiply the top and bottom of the second fraction by 3 to get that denominator to 15. I keep the denominator the same. 7 plus 3 is 10, and this simplifies to 2/3 when you divide the top and bottom by 5. So now let's go to the next page, and we'll look at this next example, which includes some negatives. So, as we talked about in those previous examples, the first thing we want to do is turn it into addition, just like we do whenever we have a subtraction problem and we're dealing with negatives. I also am going to rewrite this by putting those negative signs in the numerator. I don't want to lose them, but I also don't want them to impact my common denominator. So the first fraction, I'm going to put that negative sign with the 2. Then I'm going to make this addition, and the second fraction is positive, so I'm going to make it negative. So this problem is negative 2/3 plus negative 3/4. Now I'm ready to find a common denominator, and again, because I put those negative signs in the numerator, I don't have to deal with the negative signs as I'm working on finding my common denominator. So that's really nice. 12 would be the easiest one, so I'm going to multiply the top and bottom of the first fraction by 4 and the next fraction by 3. So I have negative 8/12 plus negative 9/12. Then the 12 stays the same. Negative 8 plus negative 9 is negative 17. And you can actually stop right there because that's in simplest form. Or you could make it a mixed number. You don't have to, but you're welcome to. That would be negative 1 and 5/12. All right, so now let's go down to the next example where we have some mixed numbers. And as we've talked about with mixed numbers, the first thing we want to do is turn those into improper fractions. And when they're negatives, we do want to sort of ignore the negative, make it an improper fraction, add that negative back on. So 5 times 6 is 30, plus 1 is 31. 6, and I'm going to make that negative. Then 2 times 10 is 20 plus 3. This would be negative 23 over 10. 30 is the easiest common denominator for me to use, so I'm going to do some multiplying to get equivalent fractions here that have the same denominator. And again, this is where, as the numbers get bigger, as I've told you, you're welcome to use your calculator as long as you're showing all your work and step by step. So 31 times 5 is negative 155, and then the denominator is 30. 23 times 3 is negative 69/30. Then the 30 stays the same. I have same signs, so I add them. I'm going to do 69 plus 155. That gives me negative 224. Now, I need to get this into simplest form. These are slightly bigger numbers. So one option would be you could do factor trees and find the LCM. You could also start simplifying it step by step. In other words, I know for sure that 2 goes into both of these, so that would give me negative 112 over 15. Okay, so I know 2 can't go in again. I could use my little tricks to figure out, so like as I look at 15, I know the factors of 15 are 3 and 5, which 5 doesn't go into 112, and if I add 1 plus 1 plus 2, that's 4, so I know 3 doesn't go in there as well. So this is going to be my final answer in simplest form. You could make it a mixed number, but you don't have to. All right, let's go ahead and go to the next page to practice a little bit more. All right, as I have said throughout this lesson, we're going to really try to focus on the problems that include negatives, since that's the newer skill here. So we're going to skip 1, 2, and 3, and I would like you right now to pause the video and try number 4, 5, and 6 on your own. When you think you have solved all 3 of those problems, you may go ahead and restart the video to check your answers. All right, let's go ahead and take a look at these 3 problems. So on number 4, I went ahead and changed those to improper fractions. Again, especially when we're dealing with negatives, I think that makes it a whole lot easier. Then 21 is the easiest common denominator to use. So when I change that, I have same signs. I add 49 plus 93. That gives me negative 142 over 21. Now those seem like pretty big numbers. So what I did is I thought through what are the factors of 21, which is 3 and 7. And 3 doesn't go into 142 and 7 doesn't go into 142. So I know that this is in simplest form. Again, that's something where if you want to divide 142 using your calculator by 7 and 3, you're welcome to make that go a little bit faster. But you could make it a mixed number, but there's no need to. You can leave it just like that. Now, as you look at number 5, I first rewrote it by putting that negative sign in the numerator. Then I found a common denominator. I had different signs. -2 plus 1 is -1. So my final answer is -1/8. Again, as we've talked about many times, that negative sign can go with the numerator or out in front. And that is in simplest form, so I'm done. And then 6, because it was a subtraction problem, the first thing I did was make it addition. And in that step of making an addition, I also put my negative signs in the numerator. Then I found a common denominator, so I ended up with -9/12 plus -4/12. That same sign, so I add them, keep it negative, that's -13. The denominator stays the same as 12. And again, that's in simplest form. I know that because 13 is prime. You could make it a mixed number, but you don't need to. You're welcome to leave it as an improper fraction. All right, so hopefully you have a better understanding of how to add and subtract fractions, some that have common denominators, some that do not have common denominators, and problems that include negative fractions as well. Have a great day.